Greetings. We're now looking at the two barista option. So we need to sketch this just so that we understand, what it is that we're doing. So if I have, if I just take the traffic of 3 baristas and divide it by 2, we're going to have this setup where I could analyze these 2 baristas independently again. And each barista is just whatever the barista was. There's no training or any other innovation here. So they're still serving at the rate of 41.1 per hour. That's per hour. But see, the total traffic here is 26.4 times 3. That, according to my calculation, was 78.9. Right. And if I divide that by 2, because I'm now shedding my 3rd barista, I'm hoping I'm going to be able to serve these clients, these customers, using just the 2 baristas. That's my scenario that I'm trying to analyze here. 78.9 divided by 2 is 39.45. So let me try that again. 26.4 times 3 divided by 2 is 39.6 per hour. So it's less than the 41.1 per hour, but it's getting up there. So let's see how this goes. It's going to zoom in here. So I want 39.6. I'm allocating the additional traffic that the 3rd barista would have seen. And I'm splitting that workload among the 2 remaining baristas. I've fired the 3rd barista now, right? It's a Poisson process. The fact that I reallocate, it'll still be a Poisson process. And I'm going to go back to my untrained setting, because all I'm doing now is I'm just firing the 3rd barista and just seeing how things are going to play. So I've got just 1 barista in each of these streams. Just to be clear, this is exactly what we had in the base case. I'm analyzing one of these baristas as an MG1 model. That is what I'm applying. So it's a G because service is a normal, arrivals of Poisson, and then there's just one. There's just this one server here. Okay, so let's see what we get. I think I may have hit submit already, but let's do that again. All right, so some things have changed here, and notably, I'm now at 96.35%. And my question is, can these baristas survive this experience? We'll discuss this, utilizations this high in the class. Also, what does my wait time now from time of entry to receiving coffee look like? Again, this is in hours, so this is 0.6339 times 60. This is 38 minutes. Okay, how many people are ahead of you? 24 in the line. Okay, so we're just documenting here, firing the 3rd barista and reapportioning their workload to the other 2 baristas. Okay, now let's suppose we fire the 3rd barista and we pool the orders. How's that going to work out for us? So I'm going to sketch it. So pool orders, got these 2 baristas, 78.9 per hour total. Still the same baristas, untrained, right? And then, the folks leave the system after that. So I can analyze this system as an MG3 model. See how that goes. So 78.9, because I've pulled the orders, still a Poisson process. There's 2 baristas. They provide service at the rate of 41.1 each. They're still all over the park with their 83 seconds, 10 deviations. So this is what we got. So what does this one look like? You're seeing that we're still at 96% on the utilization. Maybe a bit high, right? Will these folks be with you until the end of the week, or are they going to quit because they're just flat dead tired by Wednesday night? That's the question. Let's have a look and see what happened to our time, 0.2953 times 60. Got it down from 38 minutes down to about 17.7 minutes. Huge, right? Huge reduction. Whether that's tolerable is for you to decide. Now, you could also train those folks. So let's try that. So what do we do in the next, in the scenario that I'm going to analyze now? I'm going to train, fire the third barista, and have two independent baristas. So the setup now is this. So 39.6 per hour arrival. We're reapportioning the load from the third barista to the two remaining baristas. But we are going to train them. So the CV sub P squared, let's try that again. CV sub P squared is 0.00898. And the rate is still 41.1 per hour, but they're trained, right? And they are identical, these two systems. So, we can just analyze one of them as an MG1 model, and that's what I propose to do now. So the arrival rate here will be 39.6. Slow Poisson process, same processing rate, but they are now trained. And there's one of them in that system that I'm analyzing. So fire the third barista, train the remaining two, utilizations at 96%. And then what are we looking at on the time in the system? 0.3484 times 60 is 20.9 minutes. Personally, I haven't got the patience for that. Maybe I have. So it's a unique coffee bar. I'm not sure. So it's an edge case. Some days will be good, some days not. But I'm not maybe not representative. Okay, so you have to debate that issue. Still got to wonder if your baristas are going to last the week at that utilization level. All right, we're going to wrap this up by looking at pooling and training. So the way to do that is we pool all the orders. So there's 78.9 per hour coming in. We are trained. So the standard deviation on those two remaining baristas is low, 8.3 seconds standard deviation. And I have two baristas in the system. Let's see what it looks like. Okay, so those two baristas are still worked half to death. At least that would be their story. Maybe not yours. And you're looking at 0.1684, 10 minutes. Good enough or not good enough? Those are the scenarios. A lot of other thinking that can issue here, can be pursued here, and really looking forward to seeing where you settle this and what your recommendations look like. Enjoy.